into factored form. So I said do grouping because we have 4 terms here. So we should be pretty good with grouping, but in case you forgot to group, you put the first 2 terms in the set of parentheses, and then the last 2 terms in the set. And from each group, you pull out a GCF. What would be your GCF for the left group here? X squared. All right, so I have x squared, and what's left is x plus 2. And the GCF for the second group is -9. All right, so I write the factored form, x squared minus 9, and x plus 2. Although we have to factor again. What factoring method do I use on the left term here? Difference of squares. So we have to fully factor. So that left x squared minus 9 turns into x plus 3 times x minus 3. And then the x plus 2 comes down. So there are 3 factors here. Now this is a cubic polynomial degree 3. So how many total roots will there be? 3. There'll be 3 of them. Here we get each of the 3 roots from each factor. So from the x plus 3, what root do you get? What x-intercept? -3. From x minus 3, what root do you get? +3. And from 2, x plus 2? -2. Yep, we use the zero product law, but we know how it works, so we did it a lot faster. So we have 3 roots for this cubic polynomial. Let's talk about end behavior really quickly, and then we'll move on. If it's cubic, is the leading coefficient positive or negative? Positive, so we have a positive trend. What is the end behavior as x goes to -infinity on the left? We're going down to -infinity, and then on the right we're going up to positive infinity. Now looking at our equation, which one, the original in standard form or the factor form, which one is going to be easiest for us to find the y-intercept? Standard form, because what's the y-intercept here? -18. Same as the quadratic. The standard form, that constant on the end, gives you the y-intercept. And finally, if I have a cubic equation, how many turning points could this graph have? 2 of them. Okay. Good. That's just a review problem there. Nothing hard, nothing new, nothing fancy. Now we're going to work backwards, right? So I had an equation. I found its factors so I could find its x-intercepts. Well, this time I start with a graph where I know what the x-intercepts are. We have an x-intercept at -3, and we have an x-intercept at 1. How do you think we could write the factored form? What factors do I get from each of these? So again, a factor, just like above, will have an x in each one. Well, how do you think I write the factored form knowing the roots? X, what do you think? +3. Why did you say +3? Because it's the opposite. Over here, if I had a factor of x plus 3, I had a root of x minus 3. So if I would have one factor of x plus 3, what would be the other factor here? X minus 1. They're going to have opposite signs. Now I can write the standard form. If I know the factored form, all I have to do is distribute and get the standard form. So I'd have x times x is x squared. This will give me -1x plus 3x, so plus 2x, and then minus 3. I can't remember. I know I did that in Algebra 1 this year, but have we done that in our class this year? No? Okay. We did a lot of that in Algebra 1, but it all blends together after a while for me. All right, are we okay there so far? We're going to do a lot more of this today, but make it more complicated. So now we have this new function, -x times x minus 3 times 2x plus 5. Before we do anything else with this, can you tell me what the roots would be? What would be the zeros? From the -x, what root do I get? 0, right? If I set -x equal to 0, if I solved that equation, I would just get an x-intercept of 0. What root do I get from x minus 3? X equals +3. And what about the root from 2x plus 5?
-5.
Okay, I'm going to write as a fraction. -5/2, which is -2.5. Either one. one is fine. All right, so we're going to do standard form here. So standard form means no parentheses. How do I multiply together? What is a good strategy here when I have to multiply three factors together? Where do you want to start? Can I multiply, like if I distribute this x, can I distribute it to everything? No, I can't. I personally like to start on the right, but you can start on the left. But you can only multiply two things together at once. So would you rather distribute first or FOIL first? FOIL, okay. So if we're FOILing first, we're only dealing with the 2 over here. That negative x just stays out in front, and we will get to it in a minute. So we're going to FOIL the 2 on the right. I have x times 2x, which is 2x squared. X times 5 is plus 5x, minus 6x, minus 15. And you're welcome to combine like terms right now if you want to. That negative x stays out in front. And we'd have 2x squared minus 1x minus 15. So once you multiply two of the factors together, now we can distribute in the third one, the negative x. So the x will change the exponents on all of them, and the negative sign will change the sign. So this will finish out, give me a standard form of negative 2x cubed plus x squared. Now what's the last term? Plus 15x. That's the standard form. Well, what's the classification of this polynomial? It's cubic. Okay. So the maximum number of turning points that this has is 2. Now what's the end behavior this time of our graph? I have a negative leading coefficient, so is the trend positive or negative? It's negative. So we're going to sketch the picture in a minute. So negative means I start high and end low. So if I'm on the left and I'm starting high, that means that my left arrow is going up towards infinity, and my right arrow is going down towards negative infinity with this negative trend. Now we're going to build or sketch this polynomial. We've been doing sketches for a few days now, so hopefully we're okay there. First we need to mark all of our roots. We know we have, it says x-intercepted 0 and x-intercepted 3. Got a question?
Yes, you can take negative
Where?
when you bring FOIL x minus 3, negative x, negative.
Actually, because you just put a negative in front of the negative 2x.
It's not in negative, that's
Okay.
true. Yeah. I was starting to write x. I'm having a rough, like, my hand and the brain are not matching today, so I was starting to write x and I turned it into 2. Sorry guys, that's a positive 2x right there. That doesn't make it any better, but I knew what it meant. Thank you for checking. No. Alright, so I have 0, I have a root at 3, and I have a root at negative 2.5. So you need to label those points on your graph. Hopefully you labeled them on your quiz today. They were bullet points. It was like originally, that quiz had it all in a sentence, and we don't always read the directions, so I thought if we bullet pointed things, hopefully we followed the directions a little bit. Maybe, we'll see. So we start up high. Now, do any of these have a multiplicity other than 1? No, so they're not going to curve through, they're just going to cut straight through the graph. So as I start high here, I can cut straight through this root at negative 2. I'm going to turn and come back up through the root at 0, and then I have to come down through the root at 3. That does look like a cubic graph with a negative trend. That's your sketch of your parabola. Okay? You can decide how high up you want the turns. Okay. Flip your paper over. Well, now let's build a polynomial from a graph when that's a little bit more complicated than a parabola. So the graph at the right has how many turning points? 3 turning points. So what's the least degree that this polynomial could have? 4. Good. One more than the turning point. How many unique x-intercepts does this graph have? 3 of them. What are they? -2 and 3. And the leading coefficient of this polynomial will be negative. I'm just going to put a negative sign, but you can write the word if you want. Whatever floats your boat. Now, let's use the information. Let's write a polynomial here. So, if I have a negative leading coefficient, I at least have to put a negative in front of everything. And I guess actually, we can write this on the line for factored form if you want to. We'll have to rewrite it anyways, but we can at least put our negative. Now, what root? We have -3, 0, or -2, 0, and 3. I like to put the factor for 0 first. You don't have to, but I think it's the easiest for when you multiply. What's the multiplicity of the root at 0? 2. So when I put my factor, which is going to be what? What's the factor for 0? Just x. I have to make it have a multiplicity of 2. All right, what's the factor going to be for the root of -2? X plus 2, and has a multiplicity of 1. And what's the factor for 3? X minus 3. And it also has a multiplicity of 1 because it cuts straight through the fraction. So there's my factored form. We just need to multiply it together now. I'm going to rewrite it over here so we lead right into the line where I want to write the standard form. But all we need to do is now multiply all those factors together. Which two do you want to start with? All right, so we'll start on the right here. So the negative x squared comes down. That's just going to hang out with us for a minute. And when I multiply these together, I'll get x squared. What's going to be my middle term? Minus 3x plus 2x. So it'll be minus 1x. And then minus 6. What I have to do is distribute the negative x squared each term. So what do I end up with? Negative x to the 4th plus x to the 3rd plus 6x squared. So it has degree 4 like we planned. It has negative leading coefficient. And if we wanted to, we could check in our calculator and see that it was. We're almost done. So we can write an equation given a picture. Now let's talk about writing an equation when we're given different lists of roots. So here we're given the equation, or the roots, I'm sorry, not factored form, function notation form. Well, what do we know about function notation? What value, the x or the y, is inside the parentheses? The x's. So what they actually gave you here is that one of the roots is at 2/3. X equals 2/3. And x equals -5. X equals +5 and 4. So they actually gave you the x values of the x-intercepts. So we're not even going to multiply them together right now. We are going to just write the factored form. Oh, I wrote 2 over 2. I don't know. My hand and brain are not connected. All right. This one's a little different when I have a fraction. So my suggestion, or the way I think about it at least, is if I were to write a factor for this, the denominator is what's going to come up right in front of the x. So if you wrote the factor here, you would have 3x and then the opposite sign of the numerator. So if it's positive, you would write 3x minus 2. Okay, does that make sense? What would be the factor for -5? X plus 5. And what about for +5? X minus 5. And the factor for 4? X minus 4. You could put that on the line, or I had it floating in space there. And that's your factored form. Now, we learned how to find the degree from factored form. How do I find the degree of a polynomial in factored form? I count the x's, or the multiplicities. So I have 1, 2, 3, 4. So my degree is 4. And how many turning points will this graph have? Maximum of 3. So we're going to sketch a graph again. Right? We already know the roots. We're just going to sketch the picture. The more sketching we can do, the better here. So I have a root at 2/3. We'll estimate where 2/3 is. A root at -5. At +5. and at positive 4. Now, are any of these roots going to bounce off the axis? No, because they all have multiplicity of 1. Now, let's think about our end behavior. What's the leading coefficient? Positive or negative? Positive. So with degree 4, what does that tell me about the arrows? They're both going up. Right? So we start high and we end high. So when I sketch this, I start up above, circling up. I'm going to come down and cut through at negative 5. Now I have to turn because I'm going to go back up and cut through at 2/3, come down through 4, and back up through 5. And it doesn't matter how long you make the turn point part, that doesn't matter. We just want to sketch, so I want you to understand the shape of the graph and where you cut through. All right, one more, and then we are finished for the day. How many roots total do I give you? 5. So hopefully, once we make our graph, we should have a degree of 5. So this time I gave you the ordered pairs. Is that, yes, I did give you ordered pairs. So if I have a root at negative 5, what factor would that be? X plus 5. Okay. What about 1/2? Yeah, the 2x, the 2 comes up in front of the x, opposite sign. Well, what do I notice about, I have another 1/2. So I have to square the factor. It has a multiplicity of 2. What factor for positive 1? X minus 1. And for 0? X. I'm going to put the x at the front, but you can put it on the end. It doesn't matter where it goes. Well, that's my factored form. So we double check the degree just to be sure. I count up all the multiplicities. I have 1 plus 1 plus 2 plus 1, which is 5. What do we call that polynomial? Quintic. Well, how many turns do you think this graph is going to have? 4. So we're going to label our turning points. We had a root at 0, at negative 5, at 1/2, and then at 1. Okay. So my degree is 5. What is the trend of the graph? Positive. So that means I'm going to start low with my arrow and end up high. So when I sketch the graph, I have to come straight through negative 5 right there. It is a multiplicity of 1. I then go back down through the root of 0. I cut through. But what happens at the root of 1/2? It bounces. So I go down and bounce off of that root, then have to come back up through 1. So it kind of makes like a weird squiggle there. So go down, finish going up. Does that make sense? Not too complicated. And we should have 4 turns. So we have 1, 2, 3, 4 turns. We're good. Okay. All right, nothing too earth-shattering and hard there today, but we're gonna. Today we talked only about real roots. Next week we're gonna bring back I. Talk about what happens to our graphs when we have imaginary roots. Some